Okay, so this test portion here, 7.1B class 9 maths, okay? Under exercise 7.1, okay, let us start with these two congruency conditions. The first one here, A as a congruency, okay? So let us write it down along with me. Here, two triangles are congruent, so write down that. Two triangles are congruent. Two triangles are congruent if two angles and the included side of one triangle are equal to two angles and the included side again, two angles and the included side of the other triangle. So what does this mean? We're going to study that. Okay, so let us just take a case that makes it easy for us here. Now suppose you have two triangles. This is assumption. Okay, so you just draw that. So this is ABC and this is PQR. Now let us say they here if two angles and one side included. So this angle, let us say, is assumption 60 and this is equal 60. These two are equal, meaning B and Q are both 60, so they are equal. And then this C here, let us assume 40 and this equal to this R, which is also 40. Then what is the side between these two angles B and C in this triangle? AB is outside, SC is the side which is outside. So obviously BC is situated between these two angles, so that is called included between the two angles. And so included side means that. Okay, so this, let us say, is 5 centimeter. Then let us say this is also 5 centimeter. The angle, the side QR is between this 60 degree and 40 degree. So that is called the included side. So these two like this. So this theorem is saying if you find that in two triangles, two angles and the included side, means the side in between those two angles are equal to the two angles and the included side of a second triangle, then those two triangles are congruent. Okay, so by this ASA. So we write here triangle ABC, congruent sign is equal with the wave above it, triangle PQR, and we would say by ASA means two angles and the angle side between are equal. Okay, but ASA congruency condition. So this is how we understand ASA. The next one is AAS. Okay, now, okay, so according to the text, let us go there. Okay, I think we can do this here itself. AAS congruency. Now this theorem is related to this and they are used interchangeably also. Why we will come to see. Okay, so next is two triangles are congruent. Two triangles are congruent. Okay, two triangles are congruent if two triangles are congruent. Any two pairs of angles, if any two pairs of angles, and one pair of corresponding sides and one pair of corresponding sides. Okay, one pair of corresponding sides are equal. So we'll try to understand this theorem R equal, because we are going to use these two mainly, ASA and AAS congruency conditions under exercise 7.1. Okay, and okay, so SAS in the last class we did, so those three conditions. So here let us have a triangle, imagination, one and another one here, let us say A, B, C, P, Q, R. What this means is that, you see, any two angle, let us say this is 60 again, and this is also 60, therefore they are equal, and this is 40, and this is also 40. You can write along with me. Then they said any two pairs of angles, so two pairs, see, one 60 60, second pair 40 40, two angles are equal, and one pair of corresponding sides. So any side it can be. Here the condition is the side should be in between, but here the side can be anywhere. This can be here, let us say 7 centimeter, this also 7 centimeter. Then we would say that they are SC is equal to PR, isn't it? But the side is outside. So this theorem congruency condition is saying any two pairs of angles equal, and any side either between also, outside also, they are equal, then the two triangles ABC will be congruent to triangle PQR by AAS congruency, which simply means any two angle and one side are equal, then the triangles are congruent. So that means ASA can also be written as AAS, because here also two angle and one side. We wrote ASA because it's in between, but even if we wrote this same ASA can also be written AAS. Okay, so these two theorems are, it's up to you, you can use interchangeably. Okay, well, let's go to the solving part. Those are the questions there, example 3 and A2 and 3 questions. After that you can take your test. So let us do that. Here, example 3, let us say, this is on textbook page, opening your page to 128. So if we look there, diagram has already been given, so we can just draw that like this, something like this. A, B, O, and D here, and C here. So here these two are marked as equal segments. Let's write down given to us. What is given? AB parallel to line segment CD. So we can just write that short. AB parallel to CD. These two lines AB and CD are parallel. Okay. Now, once we are through with that, O is the midpoint of AD. O is midpoint of AD. In other words, there is O is the middle point of this full line, means this AO will be equal to DO. So we can write that AO equal to DO. That's the meaning. So with this we have to prove certain things. So let's just write here to prove or to show. Okay, number 1 is we have to prove triangle AOB, I think, congruent to triangle DOC. Then number 2 is we have to prove O is also the midpoint, O is also the midpoint of BC, In other words, O is the midpoint of BC means BO equal to CO. You can write that BO or CO equal to BO, up to you. That is, you have to prove BO is equal to CO. O is the middle point of this BC. Okay, so let us prove that. means our answer for that. So let us just do like this. AB is parallel to CD because it is given in the question, as you can see here. AB is parallel to CD, so we just wrote the same thing. We know that if two lines are parallel, then the angle inside here, this one will be equal to this one. We need not mark, okay? So angle A will be equal to angle D because they are, when two lines are parallel, the alternate angles are equal. So let us put this one as equation 1. Then here, if you were to put 1, let us say, and here 2, this angle 2. We know one angle will be equal to angle 2 because we know vertically opposite angles are always equal. So let us put this one as equation 2. I think that should be okay. Now let us start here as solving the first one, number 1. These two triangles congruent. So here we write in triangles AOB, and the next one is DOC. So we write that in these two triangles. Here you see here angle A, first letter equal to angle D or not. Let us check. Corresponding position of letters are same. So here A equal to D, yes. So equation 1. We've proved this already, and we can see that in equation number 1. So let us do that. And next here, 1 equal to 2. So angle 1 here inside at the vertex O, and at the O vertex in DOC is 2. They are already proved to be equal because we can see that in equation number 2. Okay, now what is the side between these two angles A and 1 in triangle AOB? Let us see that. Angle A and 1, between that is the AO side. Let us check whether this first two letters equal to this DO or not. I think they are equal. You see, already given AO equal to DO. So we write there, since given to us. So we learned just now that if in two triangles, two angles and the included side of first triangle equal to two angles and included side of the second triangle, then a triangle is congruent by AOB congruent to triangle DOC by a condition called ASA congruency, or we can also write it as simply AAS congruency also. We have discussed that just a moment earlier, right? Just before this, right? So let us put this one as equation number 3 and write once more the final answer. Triangle AOB equal to congruent to triangle DOC, as we have proved this, as you can see in equation number 3. So that's our first answer, that is number 1. We have to prove here triangle AOB congruent to DOC. Next is we have to prove BO equal to CO. So let's make a subheading for the second one. Now let's write this one again. Triangle AOB congruent to triangle DOC, since using equation number 3. So therefore, here see, BO means the third and second letter. So what are the third and second here? We know that if two triangles are congruent, we learned this in the first class, corresponding sides are equal and corresponding angles are equal. We don't need the angles in this case, and we know we can write that corresponding sides equal, corresponding angles equals generally as CP, congruent parts of congruent triangles. Okay, sorry. So that is how we solve the second one. So the second one is done. This is your second answer, right? So we'll do this A2 and 3 in the next class, okay? After that, you can take your test.